Hey guys, welcome back to the video. Now in this section, we'll actually move ahead and see how to work along with your replica set members, how to play around some configurations and how to see all the entire election process coming up. So in this particular video, we'll have a look at what exactly your election process is. So we'll see when and how exactly it gets triggered. Then we'll see how different stages affect in your replica set elections and which is the most optimal way so that you have the minimum downtime and a good quality of selection for your new primary. Okay, so now basically whenever I talk about my MongoDB replica set election, it deals with whenever your primary is down, there should be someone who can replace the primary as a new one so that there is no downtime or a minimum amount of downtime in there. Now just recall the entire replication process. So you have primary and you have some secondaries. Your primary will create op log upon every write operation, which the secondaries will absorb, execute it, and will have a data set which is as similar as the primary. Now, if the primary goes down, if a secondary realizes that the primary has gone down, then in there an election process is triggered. Now, when an election process is triggered, what happens is based on some criteria, one of the secondary will win and whoever wins becomes the new primary. Now, it works in this order. First, the priority will be considered. So normally what would happen is, let's say I being an admin, I have purchased some servers, like let's say I have 4 top-notch servers and let's say 5 commodity hardware servers. So what I'll always prefer is whenever my primary is down, one of these 4 becomes the new primary. And then if only these 4 are not available, then one of these 5 should become the primary. So what I'll do is I'll set higher priority to these 4 servers instead of these 5 servers. But let's say you don't have a priority issue, all your servers are of the same configuration, then you may decide to go for an equal priority. So you may not give reference to one of those servers. So let's say in our case, we have given the same priority to all of those servers. So what happens is out of let's say 6 available, 5 of them have the same priority. So 5 of them clear stage 1 and only 1 is discarded because he was having a low priority, and now these 5 are the probable ones to become the new primary. Now cannot have all 5, so we'll go into the second stage of replication in which we'll see the uptime. So now it will be checked which of these servers was up from the longer time. Let's say 4 of them have been up and running from last 8 hours, but the 5th one was up and running from only last 6 hours. So 4 of them have a tie again and the 5th one is eliminated. So now when these 4 of them have a tie on the uptime as well, now the next thing that would be checked is the recent op log copied. Okay, so who was the last one who recently connected with the primary before he went down? So if we check that in the status and in the configurations of the server, if we check this, let's say we find that all the 3 servers out of 4 have the same timestamp. Let's say it was 1 hour back and the 4th one had copied it 1.5 hours back. So the 4th one is eliminated. 3 of them have a tie. So these 3 go to the next stage. Now these 3 have already tied on the priority. They have tied on uptime. They have tied on the op log consumption as well. Now the 4th criteria that will be checked, or the 4th stage that they will be going through, is the proximity with the primary. Now always remember, whenever you are configuring a replica set, it is always taken care that there are majority of servers in proximity to the primary so that there is no much delay in sending the op log. Otherwise, what will happen is if your primary is very far away from the secondaries, then your op log will take the network delay to actually get copied onto the secondaries. So to avoid this, to make sure that most of the secondaries get all the data quickly, it is always taken care that the primary has more number of secondaries near him. To see this, for the new primary now, we have to check which out of these 3 who have a tie was the closest to the earlier primary. So if he was closest to one who has more number of closed secondaries, so obviously even he will have more number of closed secondaries. So let's say now we check the proximity, and out of these 3, based on the network hops, the first 2 satisfy again on a tie and the 3rd one is eliminated. So now when we have 2 more candidates tying up in this stage as well, so we have the priority tie, we have the uptime tie, we have the op log tie, and we have the proximity tie as well. So now what will happen is an actual vote out. So now all the members of the replica set will randomly launch their votes, and then whoever out of this two has the highest number of votes will win and will become the new primary. In case of tie, in this case, we have an arbiter who will have a choice of vote, and whoever he chooses will be the winner. Now basically we try to avoid the ties and everything, because whenever we have a tie, we have a very problematic situation. So we always make sure that we have odd number of servers. Okay, but there may be a case wherein your company is not giving you finance of having more number of servers just for election purpose. So what you can do is you can buy a very cheap server and you can configure him as the arbiter, so that you complete odd number of servers, so that whenever there's a tie voting, it will never happen. Basically, this guy will always have the choice of vote, and then you will always have a majority. So basically this is how all the election process of Mongo works.